Hello everyone. Today we are going to do the numericals of calorimetry and that too without knowing the theory. So can we do the sums? So let us see. First of all, we should know the formulas. So first I will write the formulas and show you and what is the meaning of each term in the formula. One by one I'll explain you. First part, there are two parts in calorimetry. First part we are doing. So the first formula we are going to use in this chapter is Q is equal to MC delta T. Now what is the meaning of each symbol? I'll write and show you. Q is equal to heat energy, M is equal to mass, small c, specific heat capacity. Delta T is change in temperature. It can be rise in temperature or it can be fall in temperature. Now the units. Energy, any energy, the SI unit will be joules. So I'm writing in red color over here with red color. Heat energy is in joules, mass kg. Specific heat capacity, we don't know the unit. So we can find instantly how to do that. In this formula, make C as the subject. So C will be equal to Q upon M delta T. So what will be the units? Energy is joules, mass is kg, temperature in Kelvin. So the unit is joules per kg per Kelvin. And while writing the units, be very careful about the alphabet. Kg wala K is small and capital K for Kelvin. So that's very important. Change in temperature will be in kelvins. I am writing SI units, but if you see in the sums, they can also give you degrees Celsius. Why? Remember, 1 degree Celsius is not equal to 1 Kelvin, but 1 degree Celsius rise in temperature is equal to 1 Kelvin rise, or 1 degree Celsius fall in temperature is equal to 1 Kelvin fall. So remember this. So that is why sometimes in the sums you can see instead of Kelvin degree Celsius also. So change in temperature it is. It is not temperature. M into C is also called as heat capacity and that is noted by symbol C dash. So hence the formula for C dash will be M into C. What would be the unit? We will see. Substituting this value in the above formula, Q is equal to C dash delta T. So what is C dash? Heat capacity. And its SI unit will be joules per Kelvin. So let's start with the first sum. By imparting heat to the body, its temperature rises by 15 degrees Celsius. So what is the corresponding rise in Kelvin scale? We know that 1 degree Celsius rise is equal to 1 Kelvin rise. Hence 15 degrees Celsius will be equal to, not 15 degrees Celsius, 15 degrees Celsius the rise will be equal to 15 Kelvin rise. Next question. Calculate the heat capacity of copper vessel of mass 150 grams and specific heat capacity is given to you. Let us write the data first. Mass is 150 grams. It is not in SI unit. So we will have to convert that into kilograms. That is dividing with 1000. They have asked find the heat capacity. So heat capacity's formula is C dash, which is equal to M into C. Substitute the values and that turns out to be 61.5 joules per Kelvin. In some new textbooks I think so it is 200 grams. So instead of multiplying with 150 gram you have to multiply with 200 grams. Method will be same. Second part, how much heat energy will be required? Q is asked and delta T is how much given to you? Let us see that. Here is the delta T. So delta T is from 25 to 35, that means 10 degrees Celsius. And they have asked Q. So Q is equal to MC delta T. Substitute the values. You can also use directly the formula Q is equal to C dash delta T because C dash we have already calculated. So 61.5 multiply by 10. So the answer will be 615 joules. Question number 3. A piece of iron of mass 2 kg. So let's write the data first. And heat capacity given to you. Find the heat energy first part and delta T is given to you 15 degrees Celsius. So let me write the data. Mass and heat capacity is given to you. They have asked you find the heat energy needed. Okay, and delta T is also given, that is 15 degrees Celsius. So using this data we can find, using the formula Q is equal to C dash delta T, substitute the values. So the heat energy needed is 14,490 joules. Second part, specific heat capacity. If you remember the formula, C dash is equal to M into C. We have to find the value of C. So C dash upon M will give me the value of C. Substitute. Hence, specific heat capacity is 483 joules per kg per Kelvin. Question number 4. Calculate the amount of heat energy needed to raise the temperature of 100 grams of copper. So mass is 100 grams. Convert this into kg. Delta T 20 to 70 degrees Celsius. So 70 minus 20, that is 50 degrees Celsius is delta T. Specific heat capacity of copper is also given to you, that is 390 joules per kg per Kelvin. Very simple question. Using these three formulas we can find the heat energy. Q is equal to mc delta T. Substitute the values and the answer is 1950 joules. Next question. Question number 6. Find the time taken by 500 watt heater. So power is given to you, 500 watts. Time is asked, small t is for time. That is the question. 50 kg of material, so mass is 50 kg. Specific heat capacity is given. Delta T is from 18 degrees Celsius to 38. So change in temperature is 20 degrees Celsius. From this data, I can find the value of Q using the formula Q is equal to mc delta T. Substitute the values. That is 960,000 joules. But on the left hand side, have a look carefully. If you remember your second chapter, work power energy, Q is also equal to PT. Q is energy. So Q is equal to PT. This is equation 1. Substituting the value of Q, that is this value over here, because Q, both are Q. So substituting now, check what happens. So 960,000 is equal to power is 500, time we don't know, hence time will be equal to 1920 seconds. Convert this into minutes by dividing with 60. So dividing with 60, you will get the answer in minutes. So that turns out to be 32 minutes. Question number 7, exactly similar. The only difference is now time is given. They have asked you find heat capacity and specific heat capacity. Let me write the data. So for this we can use Q is equal to PT. Okay, substituting the values, 60,000 joules. The remaining data, 4 kg of liquid, delta T is given from 10 degrees to 15 degrees Celsius, that is 5 degrees Celsius. So writing that also. In the first part, they have asked you find the heat capacity. So we can use the formula Q is equal to C dash delta T. Okay, Q, we already know the value. Substitute over here. That is 60,000. That is 12,000 joules per Kelvin. Last part, that is find specific heat capacity. We know that C dash is M into C. We have to find the value of C, that is C dash upon M. Again, substitute the values. C dash is 12,000. So the answer is 3000 joules per kg per Kelvin. Question number 8, 0.5 kg of lemon squash. Now what is this lemon squash over here? That is nothing but water, sir. How do you know? Look at the value of specific heat capacity. 4200 joules per kg per Kelvin. That is the specific heat capacity of lemon squash. That is water only. But they have already specified at the end of the sum. Specific heat capacity of lemon squash is. Okay, so don't worry what it is. Writing the data. Mass is 0.5 kg, change in temperature 30 degrees to 5 degrees. So big minus small, always remember that. So 25 degrees Celsius. Now they have asked, a refrigerator can remove heat at an average rate of 30 joules per second. Sir, don't know the statement. We don't understand. What is the meaning of that? Look at the units carefully. Average rate of 30 joules per second. 30 joules per second is nothing but equal to 30 watts. And watt is the unit of power. So indirectly power is given to you. Fine. How long will it take? It's a normal sum now. Time is how much. Specific heat capacity is also given to you. So we can write Q is equal to PT. Q is also equal to MC delta T. Hence I can write PT is equal to MC delta T. Substitute the values. That is 1750 seconds. If it is more than 60 seconds, sorry, convert it into minutes and second. How do you do that? By dividing by 60. So let me do that. Look at the calculations carefully. So 175.6 minutes. Still the answer is not complete. Convert this into minutes and second. Write this in mixed fraction. After writing in mixed fraction, this part, that is 29, that will remain as minutes. So 29 minutes. And the fraction part, convert again back into seconds. How do I convert? 1 by 6 minutes into 60 seconds. That is 29 minutes and 10 seconds. Question number 9. But before starting this question, now whenever two things are mixed, then one more concept we have to remember, that is principle of method of mixtures. What is that? It is also called as principle of calorimetry. So writing it. So this principle says heat lost by a hot body, heat energy lost by a hot body will be equal to heat energy gained by the cold body. So let us use this in this sum. Step number 1, metal is hot, it is at 150 degrees Celsius. So heat is lost by the metal. So writing as per the data. Same formula MC delta T, just substitute the values. Now delta T will be how much? Metal is at 150 degrees Celsius and the final temperature is 20 degrees. So how much is the delta T? 150 to 20. So 150 minus 20 degrees Celsius. So this is heat lost by metal. It is added to water. So now heat gained by water. Same formula MC delta T, so that you should not get confused. We can write it as M1 C1 delta T1. Okay. Substituting the values. What is the delta T? Water, which was at 11 degrees Celsius and its temperature rises to 20 degrees. So heat is gained by water. So 11 degrees to 20 degrees. So what is the delta T? 20 minus 11. So that turns out to be 9. Now applying principle of calorimetry, what it says, heat lost by metal will be equal to heat gained by water. Substitute these values. So you have final answer C is equal to, and always round your answer till three decimal places. So 0.582 joules. This time we have used grams, so per gram per Kelvin. Similar question, 45 grams of water at 50 degrees Celsius in a beaker. In a glass you have 45 grams of water. Here's the diagram, just a sketch. You need not draw it in the exam, it's okay. Copper is at 18 degrees Celsius, water is at 50. So let the final temperature be something, anything between 18 or 50, whatever. Okay, so it can be 20, it can be 25, we don't know that. So we have to find that. So let us say the final temperature is X degrees Celsius. Now from 18, okay, copper will go to say 20. Assume that X is 20. So it is reaching from 18 to 20. So that's how it is. So how much is the delta T? 18 to 20. So it will be X minus 18, big minus small. See, X is 20, assume just a number 20. So 20 minus 18. So it will be X minus 18, not 18 minus X. These sums are very simple. Students do mistake by writing 18 minus X. How to remember? Assume this as 20 degrees. Okay, later on you can erase it. So 20 minus 18, big minus small. So that is X minus 18. And what about water? It is going from 50 degrees to 20 degrees Celsius. So temperature is falling down. So let us calculate that also. Again, big minus small, 50 minus 20. So it is 50 minus X, not X minus 50, because this is 20, right? 50 minus 20. So 50 minus X. Now you can erase this 20 part. Again, by principle of calorimetry, heat What is happening to copper? 18 to 20 it is going. So heat gained by copper is equal to heat lost by water. Same formulas, mc delta T here also. So here also mc delta T. So mc delta T, everything gets cancelled. So we are not supposed to cancel. To show that they are different. That was for copper, this is for water. So I'll just change the sign. That was mc delta T, m1 c1 delta T1. Okay. I have substituted the values. Now pay attention nicely how to calculate, how to divide. Okay. 1 0 1 0 gets cancelled, 1 0 1 0 gets cancelled, 5 1s are 5 9s are 3 1s are 3 3s are 3 3s are. Okay, now opening the brackets. Hence, on collecting the like terms on one side, we get 139x is equal to 6534. X is 47.007. That is why if you have a look carefully in your textbook, it is printed as 47 degrees Celsius approximately, rounding up. Okay. Question number 11, similar to question number 10. There we were adding copper to water. Now you have hot water in one vessel, to that you are adding cold water, or vice versa. To cold water you are adding hot water. So mixing two things together again. So principle of mixtures, that is principle of calorimetry, will be used. Let me write the data. So here is a sketch diagram. 200 grams of hot water, which is at 80 degrees, is added to 300 grams of cold water, which is at 10 degrees Celsius. So final temperature will be between 80 and 10. It can be 20, it can be 25, it can be 30, 40, 50, 79, whatever. But it will be between 80 and 10 degrees. So let the final temperature be X. As I told you in the previous sum, assume anything between 80 and 10, say 50 degrees final temperature. Okay? So now hot water is coming from 80 to 50. So how much will be delta T? 80 minus 50. So that is 80 minus X. Similarly for cold water, how much will be the delta T? 10 degrees to 50. So 50 minus 10, big minus small. So X minus 10. Now let's erase that 50. That was just an assumption. Again by principle of calorimetry, heat lost by hot water will be equal to heat gained by cold water. Substituting the values, I'll take this as mc delta T. The other one I'm taking it as mc delta T1. Why sir you are not keeping C1? Because both are water. C and C will get cancelled straight away. Substitute the values. And finally open the brackets, but before that you can reduce the numbers to smaller numbers and then you can open the brackets. So how much is X? Tell me. Perfect. X is 38 degree Celsius. Next question. Similarly, I am keeping the diagram also same. So first I will show you the 12th question. Everything same, a small change. Let us see what is that change. Here is the question. I have not changed anything. The writing part, everything is same. I've just deleted the numbers. Okay. Temperature of 600 grams of cold water. So cold water this time is 600 grams. Rises by 15 degrees. So delta T straight away given to you 15 degrees Celsius. Delta T. When 300 grams of hot water. So 300 grams of hot water whose temperature is 50 degrees Celsius. So from 50 degrees, it is coming down to say 30 degrees. Assumption just. Okay. So what will be the delta T in this case? Big minus small. So 50 minus 30. So hence we can write 50 minus X. Final temperature is same. Okay. And this side we don't need at all delta T because it is already given to you. Fine. Substituting the values. Heat lost by hot water is equal to heat gained by cold water. Right, C and C gets cancelled. Mass, so I'm substituting the values, check. 300 twos are, so finally you are left with 50 minus X equals to 30. So X equals to 20 degrees Celsius. That is not the answer. They have asked you find the initial temperature of cold water. Therefore, initial temperature of cold water will be how much? 20 minus 15 because delta T was minus 15. Hence, 5 degrees Celsius is the answer. Question number 13. 1 kg of water is contained in 1.25 kilowatt kettle. Calculate the time. So let me write the data. 1.25 kilowatts multiply by 1000, you get watts, SI units. Delta T, big minus small, 25 to 100. So big minus small, that is 75 degrees Celsius. And specific heat capacity of water is given. Same thing according to principle of calorimetry, heat lost, or you can write the way we have done earlier, Q is equal to PT. Q is equal to MC delta T. Both are Q, hence I can write PT is equal to MC delta T, substituting the values. While doing this sum, be very careful. The value of C is given in SI units, 4.2 joules per gram per Kelvin, and I have taken it as 4200 because everything is in kgs. I have taken SI units, I have taken. Okay, look at the calculations. 1 0 gets cancelled. 25 5s are 25 3s are, okay, 5 8s are 40, 5 4s are 20. So let us write this. It is 84 into 3 seconds. If you remember, I told you it is more than 60, so convert that into minutes, dividing by 60. 6 10s are 6 14s are, again 2 7s are 2 5s are. So you are left with this 21 upon 5 minutes. Write in mixed fraction. 5 4s are 20. So that many minutes. 4 as it is 4 minutes, and 1 by 5 convert back into seconds. That is 1 by 5 into 60. That is 4 minutes. 12 seconds is the final answer.